Hi everyone. Today I'm going to show you how to repair a stripped out frame bolt hole on a BMW R1200 RT. Pretty sure all the R1200s are the same. This is an 08 model. I don't know about the later models. Okay, so here you have the main rear subframe bolt which holds it, and this one, which is stripped out like the one on the other side, is the attachment for this little subframe arm which comes off the front subframe. First thing to note is that this bolt that goes in here doesn't clamp the rear frame. Actually, the head goes right into it. It only clamps that to the aluminium of the engine. The dealer said they would need to basically disassemble the bike because you would need to take off the rear subframe and the front subframe in order to do this. I'm going to show you today how to do it in situ. If you have a look, you'll see I've already removed the fairing, the tank, the throttle bodies, and I loosened up the airbox. I was hoping to get the airbox out, but that proved undoable from the top. With this hole here, you need to make sure that the smaller hole for the subframe, you can see that moving now, is lined up in the centre of the hole in this outer frame. And you've got to make sure that's lined up before you start drilling. What are we going to need to do this job, I hear you ask? We're going to need an electric drill. Doesn't need to be a high powered one. Very handy if you happen to have a vernier like this, but if you don't, you can do it with an old-fashioned ruler. The very minimum you're going to need a coarse file, or ideally a bench grinder like this. If you don't have a bench grinder, you could, if you're very skilled with an angle grinder, use an angle grinder. If you're not skilled with an angle grinder, don't attempt it. You will end up grinding your fingers off. The other things we're going to need here, we'll need some tape. I use insulation tape, a 50mm long 12mm metric bolt with a 1.75 pitch. The pitch is the distance from the top of one thread to the next. This bolt's too long, but I've just got it here to show you the head size. And we're going to end up grinding that head size down to that size there. We're going to need a tapping drill, which will be 10.2 to 10.4 millimeters. I used a 1332, which comes into that range. You need a clearance drill for that subframe I was moving. That could be up to 2.5. I used a 3164, which is a bit under that. Gives a slightly snugger fit. A tap, 12mm tap, 1.75 pitch. To turn the tap, you need a tapping wrench like this. And you also need an extension to go on the tap because it's a long way from where the bolt is out past the heads. This extension I'm using is a 1/4 inch drive socket extension, standard 1/4 inch drive, and the tap just fits in there. You use the extension the wrong way around, and then this handle will actually go on there. The other thing we need is some cutting compound for the tap. If you have a torque wrench, you can tighten those bolts to 38 Newton meters. That's what my workshop manual says, or convert it to whatever other units you're using. Now, why have I got red tape on these drills? I put it on there to show me how deep to drill. So here, that's 65 mils from that corner there to the tape, and on this one it's about 20 mils. This one here I'm doing now is actually very important. If you go too deep, you'll end up drilling into the metal body that we need to tap the thread into. You can actually check if you've done it deep enough when you've drilled that hole with a clearance drill, just by moving that little subframe like I did, and if you see the hole you've drilled moving, you know it's still part of the subframe. If it's not moving, it's part of the aluminium. Don't go too deep. That's why the tape's there, same reason on the tap, just it's a depth indicator. Couple of things before we start drilling. You'll notice here I've wrapped a rag with a bit of tape around the end of the injector. That's to protect the O-ring and the injector. Always bung something in the hole here. You don't want swarf, little bits of iron filings or anything you drop going down inside the engine. Unfortunately on this bike, the cover which is supposed to be over the top of the clutch is missing. I only found that out when I started this job. And you'll notice there's a rag in there. I don't know if you can see it. Now, on the end of the hole, you can sort of see a darker brown. That's a bit of grease I put in there. That's to catch any filings off the drill on the other end of the hole. It's right in there, it's hard to get at, so I put some grease in there and that'll catch the filings. So all we do now is I put the drill bit in the drill. This is the tapping drill. It's basically the just over 10 mils diameter tapping drill. Put it in there and we drill. Before we do, it looks pretty good to me. It's nicely lined up. And I can see all the way through the hole, so that's a good sign. I'm just going to put the drill. Now, if you're not used to using a drill, you must keep it square. And by that I mean it can't be on an angle that way, it can't be an angle up. Maybe I'll show it back here. It can't be up or down or back or forwards. It's got to be at a dead square angle to the bike. And you just go slowly. There's no rush here. And if it catches, you just stop. It's better if you don't use a really powerful drill. A drill like this, the battery drill is good because it's got it on a low setting, so it doesn't, if it grabs, you can just reverse it. I need two hands, so I'm going to turn the video off while I drill this. So we're drilling now. I've got the drill most of the way in. As it goes in, you pull it out to clear the swarf out. Pull it out. And that's pretty much all. Just go in until the tape is level with the outside like that. That's far enough. What I'm going to do is I'm going to clear all of those filings out of there before I do anything else. Two reasons. I want to keep it clean in back there, in the back, and I want to keep it clean for the tap as well because that makes its own filings. Now I'm going to change the drills out. So we've run that drill all the way through and it's nice and clean in there now. And I'm going to put the bigger drill, and that's just going to drill only through this piece of metal here, but not into the metal behind it. And that's so that the 12mm bolt won't be threaded in this section, but will pull it into the engine like it's supposed to. Now, I've changed the drill out. Now the critical thing here, again, you've got to keep it straight and don't drill too far. You can't go any further than that red line on the drill. What we're drilling through is steel, which is hard, and on the other side of it is aluminium, which is soft. So if you go all commando on it and give it a lot of pressure, pushing pressure, you're going to end up drilling into the aluminium that you need the thread in. So you just have the drill going reasonably fast and you don't push on it too hard. And you get ready to just release the trigger the second that you feel it change. When I feel it feeling as though it's about to break through, I just stop and do it in little squirts like that. It might jam. It's alright, you can reverse it if it jams. That's as far as I'm going. See, it's up to the red. What I should have done first is take the tap and dip it into this. This is a special cutting compound. This one's called Trefolex. It's used in the engineering industry for cutting. You can use it for drilling or for tapping. Now you line this in like this. You line it up. Now it's very important to do this straight. You've got to be nice and straight. It pretty much lines itself up. Oh, there's one other thing I'll say about this tap before I get going. If you look at the end of that tap, it's a bit messy now, there's a bit of a taper on the end. But some taps are tapered about a third of the way up. You want one like this for this job, if you've got one. You can use the other one, but you'd have to run it further through. And if you have the cover on your clutch, it's going to go into that. Okay, so now you just turn it a little bit. You do it gently. I'm doing this one-handed, so just turn it and you can feel it cutting. To start it, you turn it probably about one, maybe. When it starts to get hard, you turn it back and it kind of clicks. Turn it back again. Now I'm going to take this out and just check my hole alignment, because it's important now too. And you see it's not right. I don't know if you can tell from that, but the subframe member, the one at the back, has moved a bit further forwards. I'll just stop and adjust that. You just take it up to where you can feel it's cutting, quarter of a turn, and then back. Never force it. Quarter of a turn and then back. Because we have such a long handle here to clear the head, you have to be very careful not to push laterally on it. Don't push down or up, or you could snap the tap off. So just keep everything nice and straight. That's up to the cutting point now. Just a quarter of a turn and back. The reason going back is as it cuts, these cutting edges here peel off a curl of swarf, and if you go far enough till it gets to the last one, it jams. So you go back and breaks it off. Again, what I'm going to do is I'll get the tap about a bit further in, and then I will pull it all the way out, clear all the swarf out of it, put a bit more cutting compound on it, and put it back in. Okay, now I'm going to take this out and clean out the threads. You can see all the swarf on there. And I'll just get a rag and just clean it out of the grooves like that. Of course, if you're experienced with tapping holes, this will be boring you shitless. But I just thought that I didn't want people attempting to tap holes with no idea how to do it and end up breaking the tap in the bike, because that would be disastrous. It's very difficult to get out a broken tap because it's hardened steel. You can't drill it out. Okay, so that's fairly clean now. Let's give it another dunk in the cutting compound. And back in the hole. I'm running it back in the thread I've already cut. That's why I'm not going backwards. As soon as I feel it getting up to that tight spot where it's cutting, I'll start doing the old forwards and backwards routine. So I've cut quite a way in already. Okay, now it's cutting. As you get further in, the whole length of the tap is cutting all at the same time, so it does get a bit tighter. But just as an indication, if it sort of jams up and the whole shaft of the tap is flexing, you want to avoid that. getting there, and I can see the inside end of the hole. You can't on the camera, but I can see it from here. And I'm going to go until I can see the end come out a little bit. So I might go a bit deeper than my my red line there. And already it's started to ease. See, I can just turn it. That means it's finished cutting. I'm going to run it a bit further because just to make sure the threads cut all the full length. Okay, now I'm going to run it out again. Now remember that this bolt's, the job of this bolt is not to clamp both frame members to the engine, it's only to clamp the inner frame member. So the head of the bolt has to fit inside that larger hole, and it doesn't. So we have to make it smaller. Okay, that's that done. As you can see, the head of this hex bolt, Allen bolt, measures around about 18 mils, and the hole inside the frame that it has to fit into is about 16 mils. So we need to make this narrower. You can sort of see a bit of a chamfer on the edge of the top. And if I grind back just past the chamfer, then that's enough, and there's still enough metal on there to tighten it. Next thing I'm going to do is I'm going to wrap some tape around the thread on this bolt. The reason I'm doing that is to protect the threads, so I'm going to put it in the drill while I grind it. You'll see what I mean in a moment. That protects the threads, tighten it up. Okay, now we go over to the grinder. Now the drill's reversible, and in one direction it will loosen the chuck, but it's always better if you can have the drill going the opposite direction to the grinding wheel. So the grinding wheel is going to go that way, down, and it'll be better if the drill's turning so it's going up. You can do it the other way, but what you don't want is for the chuck to loosen up. So I'll just start it up, give it a quick touch so you can see what I'm doing, and then I'll do the rest off camera. And the other thing is it gets really hot, so don't touch it until you've cooled it off a bit. Okay, now I know this is not small enough yet, but I'm just showing you. If I can get in there. So I've taken nearly a millimetre or so off that. So you just got to keep at it. The advantage of doing it in the drill is that you get it off fairly evenly. It's no use if you get it off all on one side. You can do it by hand if you don't want to put it in the drill, but then again it gets hot and you're holding it. You can do it with a file. It's going to take a long time with a file, or an angle grinder would also be doable. So I'm going to go back and take some more off this. Put that in there to cool it down. I'll burn myself. So back at the bike, we just try the head in backwards to see if it's going to fit in the hole. It does, as you can see, fits in. A little bit of room. Now the only thing we have to watch out for here is if you've ground it slightly off centre on the head, it still might not fit when you screw it in. Let's just try it out. I'm going to need an Allen key for this. It's the wrong size Allen key. How is that possible? Try this one. That should fit. That's going in quite nicely. Now, you wouldn't normally take this much metal off the head of an Allen bolt like that, or a set screw like that. However, since it's going into aluminium, and we know that we don't want to strip the aluminium out, you're not going to be applying huge force to it to tighten it. It just needs to be tight enough. Nearly all the way in. As it's going in further, it's getting a bit stiffer, needing a bit more force, but not too much. I can still do that one-handed. The Allen key up that way. It shouldn't get really tight until it's all the way in. If it does, you're going to have to pull it out and take a little bit more off the head. The other thing you could do is get a slightly larger drill and just drill out a tiny bit off the hole in this frame, but that would be a last resort thing. And this just screws in here nicely. It's got a way to go yet. And that's pretty much all the way in now. If you can see where, hang on, I'll get the focus happening. If you can see where the head of the bolt we've ground is sunken in a little bit from the frame, and what it's done is it's pulled this frame here into the engine mount, into the frame mount, and it's actually quite tight. One-handed I can't move it, two-handed I can get a little bit on it. Don't put a lever on there, don't be tempted, because you're going to strip it out and you'll be back where you started. And that is how you fix up a stripped out frame bolt on a BMW 1200.